control system can be described in 3 or 4 ways. In the previous classes, we have seen finding a transfer function for an electrical system, for mechanical system, and when differential equation was given. Transfer function is an important mathematical model of a control system. So, system can be even expressed by block diagram, and the components of the block diagram are summing point and block and takeoff point. Control system consists of several summing points where signal can be added, 2 or 3 signals can be added depending on the polarity. It can be added or subtracted, and it is a block. The functional description of the block is represented in it, or gain of the block is given by G. So, this is another component of the control system block diagram. This is another point, takeoff point. The meaning of takeoff point is that same signal can be taken to different locations. Say this output is Y. So, when I say takeoff point, signal should be available at some other location. So, these are the 3 components of block diagram, but any system, when it is represented in the form of block diagram, it may consist of several blocks, several summing points, several takeoff points. System may looks very complex, but I am interested in overall transfer function of the system. So, I must use some rules for block diagram reduction, and ultimately any system having several such components, I will make them to a single block. This is called overall transfer function, and then it has only either input and then output. So, I need to reduce the given block diagram into a single block whose overall gain is represented in it, then I can do analysis. Doing analysis of each and every component is very laborious and complex. Instead of that, if I get the overall transfer function of the system in terms of a single block, analysis will be very easy. What kind of analysis we do with the help of transfer function comes later, but today we will try to focus on what are the rules developed to reduce the given complex diagram into a single block and finding the overall transfer function. We just see with some examples. So, what are the rules for block diagram reduction? Rule 1, when blocks are in cascade. Blocks are in cascade. Say G1, G2 and G3. So, all these blocks are in cascade. All these blocks are in cascade. So, when I say X is the input, Y is the output. So, I can reduce this into a single block. So, this is said to be G1, G2, G3 block gains are in cascade. So, I can reduce this into a single block X, G1, G2, G3 and then Y. So, 3 blocks reduced to 1 block. This is what block diagram reduction rule 1, that when the blocks are in cascade, the resultant will be product of individual gains.